All right, welcome to 10.07. We're going to take a look at a couple of AP free response problems that deal with differential equations. All right, this one here is from 2006, is from Form B and number 5. Go ahead and jot down this question here in your notebook. Answer parts A, B, and C on your own to the best of your ability. We'll take a look at these solutions together, and then I'll give you one more to try on your own. Alright, so when I sketch the slope field, I want to take note of x or y values that will make the slope 0. And the most obvious one is when y is equal to 1, we're always going to have a slope of 0. So I'm going to start off by sketching those slopes, as I've done there. And from that point on, I can just sort of go down to my second row here. And this is when y is 0. So I'm always going to have negative 1 squared, which will be positive 1. In other words, I'm just dealing with cosine of pi x. So I have cosine of negative pi, which is a 180-degree turn, and cosine there is going to be negative 1, so I'll have a slope of negative 1. Cosine of 0 is positive 1, so I'll have a positive 1 here, and cosine of 1 pi is also negative 1, so it'll be a negative 1 there. Moving down, now when y is negative 1, I'll have negative 1 minus 1, which is negative 2, squared, and negative 2 squared is 4, so now I'm going to have 4 times whatever cosine is. And I know cosine here was negative 1, so it's going to be negative 1 here as well, and 4 times negative 1 is going to be negative 4. So it's going to make my slope much steeper. Same thing here, much steeper, it's going to be positive 4 and then negative 4. And there is my slope field. You're going to get 1 point for the slopes that are 0 and 1 point for all the other slopes. And this makes part B a real piece of cake. It just asks what the C value needs to be such that the line y equals C satisfies the differential equation here. And all I have to do is look at my slope field to figure out where a straight line would work. And that would be a straight line going straight through y equals 1. So what I can say is that since y equals 1 is a solution, C is equal to 1. And you get 1 point for that correct C value. For part C, I need to separate my variables and anti-differentiate, and so I'm going to multiply by 1 over y minus 1 squared and by dx on both sides. That gives me this situation here, and then I'm going to take the antiderivative of both sides. So taking the antiderivative on the left, you might want to make a u substitution here, and so I'm going to show you what this will look like over here on the right. So the u substitution that I could make is that u should be y minus 1, and if I do so, then du is going to be dy, and that gives me a nice easy antiderivative, the antiderivative of 1 over u squared du. And in any situation where I have some power in the denominator, I'm going to move it up to the numerator, and that is going to make my life a lot easier. So I'm going to end up having the antiderivative of u to the negative 2 du, which is negative u to the negative 1 plus c. Now, u to the negative 1, that's 1 over u, so it's negative 1 over u plus c, and substituting back in my u, I'm going to end up with negative 1 over y minus 1 plus c. So that is the antiderivative on the left, and the antiderivative on the right is just going to be 1 over pi times sine of pi x plus c. Shouldn't be too hard to see. That is pretty clear over there on the right. At this point, I'm going to use the initial condition to solve for c, and doing so is going to give me a c value of 1. So at this point, I can go back using my c value now in my equation and solve for y. Note here that I have a negative out front, so if I multiply the negative in to the denominator here, I'll have negative y plus 1, which is just 1 minus y. So I can rewrite the denominator as 1 minus y. And now I have a situation that's a little bit easier to work with. Over here on the right, notice that I have 1 over pi. And if I look at what I'm going to do on the left, I want to get y into the numerator. So I'm going to take the reciprocal of both sides at some point. And that would make it a lot easier if on the right I didn't have any fractions. So what I'm going to do is I'm going to multiply by pi on both sides, and that will allow me to get rid of this 1 over pi. So doing that is now going to give me pi over 1 minus y, and on the right, pi times 1 over pi is just 1, so that goes away, and then 1 times pi is pi. At this point, I can then go ahead and actually take the reciprocal of both sides and multiply by pi on both sides. So notice that taking the reciprocal over here is going to leave me with 1 minus y over pi, and then over here I'm going to have 1 over sine of pi x plus pi. And then I'm going to need to multiply by the pi on both sides to get rid of it on the left, so I'll have 1 minus y, and over on the right now I'll have pi over sine of pi x plus pi. I'm almost there. I want y by itself, so I'm going to add y to both sides and subtract this from both sides, and that's going to leave me with y equals 1 minus this thing over here, which is pi over sine of pi x plus pi. And so that is going to be the particular solution. One thing that I want to note is where this is valid, and this is actually going to be valid for all x values between negative infinity and positive infinity. You can check by looking both at your particular solution and the derivative that it will be defined for all those values. Here's the way the scoring worked out. You got 1 point for separating your variables, very important. You got 2 points for taking the antiderivative, so if you got the antiderivatives correct, that was 2 points. You got 1 point for having a constant of integration, c, and combining it. That's very important. You get 1 point for using your initial condition to solve for c, and then you get 1 point for your final solution. So as you can see, this is worth 6 points, very important to be able to solve differential equations. All right, I'm going to give you one more to practice on your own. All right, so this question is from Form A in 2006, number 5. Go ahead and copy it down, work through it on your own. Give yourself 15 minutes, see how far you get in 15 minutes, and then finish out no matter how long it takes, and we'll take a look at the scoring tomorrow.